अभिषेक, अक्षता, आनंद, अंजुम, बसवराज गडकरी, बसवराज ऐनापुरे, भाग्यश्री, भक्ति, भारती, चेतन कुमार, दीपक, दिव्या, गणपत शिवाजी, ज्योति, किरण बिगाड़े, लक्ष्मीकांत, महातेश, मुलेप्रेम, नागेश, नंदीश, पूजा,
सर रोल नंबर
22 पूजा,
Present,
right.
sir.
प्रमोद कुमार, प्रवीण, प्रियंका, संध्या, संतोष पुजारी, संतोष, प्रियंका, ओके, राइट. शाहबाज,
Present, sir.
ओके. शफिया,
Present, sir.
राइट. श्रीधर सोलकनवर, सृष्टि, सिद्धार्थ वर्णेकर, सिद्धार्थ पाटिल, सुप्रिया, वंदना, वसंत, वेदत्ता, योगेश, महेश, बालेश, तैक मोहम्मद, प्रवीण, अभिषेक, ऐश्वर्या, ओके. अमानुल्ला, बंडोरकर तनय मोहनदास, भावराव, शोधन,
प्रेजेंट सर.
राइट. देवण्णवर अनिल कुमार शेखप्पा, नंद कुमार, प्रमोद, रोहिणी, रोहित अलवाणी, शशिधर, श्रीधर, स्नेहल, वैष्णवी, साईश, कार्तिकयम, स्मिता, सॉरी, you are able to see the screen, students?
Yes,
My
sir.
face is visible?
Yes,
Or it is,
sir.
dark and dull. Visible, right? My face is visible. Shafia? My
Sir.
face is visible, my face.
Yes, sir.
Fine. Let us start with the new topic. It is next half of the module 3, programming 8051 timers. Programming 8051 timers. How many timers are there in 8051 microcontroller? You have already studied the features. How many timers are there? Number of timers. How many timers are there?
2, sir.
2 timers. Which are those?
T0 and T1.
Very good. T0 and T1. Timer 0 and timer 1. Okay. These are the 2 timers of 8051 microcontroller. Right. Now, how many bit registers are these timers? There are 2 timers, timer 0 and timer 1. Each of these timers are of 16 bits. Is it not? Each of these timers are of 16 bits. They are 16-bit registers. Right? Timer 1 is a 16-bit register. Timer 0 is also a 16-bit register. Now, as these timers are 16-bit registers, and the 8051 microcontroller is a 8-bit microcontroller. Why it is 8-bit microcontroller? The reason you know that because the data bus is of 8 bits in 8051 microcontroller, and hence the 8051 microcontroller is a 8-bit architecture, or it is a 8-bit microcontroller. Correct? Now, as it is 8-bit microcontroller, it cannot access 16-bit at once. Because it's having a data bus of 8 bits, it cannot access all the 16 bits of timer registers at a time. Hence, what is done is, in the architecture, the timer register is split into 2 registers. Timer 1 is split into First half 8 bits, then upper half next 8 bits. Total it is split into two registers. Right? Timer 1 is split into two registers. Timer 1 high, timer 1 low, and timer 0 is split into two registers. Timer 0 high and timer 0 low. Okay, this is how the registers are being split. All right, that is what is explained here. 8051 has two timers bar counters. The timer acts as a timer and also as a counter, and hence it is called as timer bar counter. The timer that are there in 8051 microcontroller, they act like a timers, that is to provide the time delay, and they also act like the counters for counting the number of events. They can be used either as a timer to generate the time delay or as counter to count the events that are happening outside the microcontroller, to count the number of events, right? How many pulses are there, right? To count the number of pulses in the pulse train of pulses, right? To count such events, the counter is used. The timer is used as the counter. And if it has to generate some delay, if you want to generate some delay between two actions, right? If we are performing one action, one job, one work, and in the next, when you want to perform the next work or the next job, there has to be some delay in between. To provide that delay, the timers are used. Timers are used to generate the in between time delay, the event time delay. Okay. The two timers are timer 0 and timer 1. Each of these timers are 16 bits wide. Since 8051 has 8-bit architecture, these 16-bit timers are accessed as two separate registers of low byte and high byte. Now, how they are accessed? The 16-bit register of timer 0 is accessed as low byte and high byte. The low byte register is called TL0. Note that the lower byte of timer 0, it is called as TL0, which means timer 0 low byte or timer low for 0 timer. And high byte register, that is TH0. TH0 means timer 0 high byte, timer 0 high byte. Okay. Now these registers can be accessed like any other registers, like how we are accessing A register or B or R0 or R1, right? Like how we are accessing the other registers, we can access these registers also in a similar way. Example is instruction move TL0, hash 4FH. Whether this is read operation or write operation into the timer register. Tell me, move TL0, hash 4FH, whether it is read operation or write operation into the timer register. Whether it is reading the data or it is writing the data. Look at this instruction, move TL0, hash 4FH. 4FH is the, sorry. 4FH is the value, right? And this value is moved into TL0 register. So how it is, whether it is a read operation or write operation? Who will tell me? Yes, please.
Read, sir.
It is write operation. Move TL0, hash 4FH is a write operation. Okay. Because 4FH value is written into the TL0 register. Okay. Right. Now similarly think of move R5, TH0. Whether tell me whether it is read or write. Move R5, TH0. Just a minute. Sorry for the interruption. Whether it is read or write, move R5 comma TH naught.
Read.
It is read because we are reading from the TH naught register, from the timer register, we are reading into the register R5. Correct? It is read operation. Okay. Timer 1 is also 16-bit bytes and 16-bit register. That is timer 1 16-bit register is split into two registers, timer 1 high and timer 1 low. These register, that is timer 1 registers TH1 and TL1, can also be accessed as similar way, in a similar way as that of the timer 0 registers. How we access the timer 0 registers? In a similar way, the timer 1 registers are also accessed. Next is TMOD register. Timer mode register. The full form of TMOD register is timer mode register. Timer mode register. Now, in this timer mode register, it's a 8-bit register and it is not bit addressable. Not bit addressable means we cannot access individual bits at a time. I have told this in the previous classes. There are two types. One is bit addressable and the not bit addressable. Bit addressable means we can read or write the individual bits into the registers. It is called bit addressable. Not bit addressable means the opposite. That is, we cannot read and write single bit into the register, but we can read or write the entire byte. Entire byte of data can be read or written into the register. That is called as not bit addressable. Bit addressable, not bit addressable. This TMOD register is not bit addressable. That means we cannot read or write the single bits. Both the timers use the same register, that is the both T0 and T1, timer 0 and timer 1. They use this TMOD register for performing the various or for setting the various operation modes of the timer. To set the various operating modes of the timer 1 and timer 0 register make use of TMOD register. Now let us see what is this TMOD register. TMOD is 8-bit register. It's a 8-bit register. Of course, all the registers are 8 bits. TMOD is 8-bit register in which there are two parts, the upper 4 part and the lower 4 part. The upper 4 part is identical to the lower 4 part. Right? The upper 4 part is same as that of the lower 4 bits, in which lower 4 bits is for timer 0 and upper 4 bits is for timer 1. The upper 4 bits is for timer 1 and the lower 4 bits is for timer 0. Okay, this is the TMOD register in which we are having the bits gate C/T bar M1 M0. These are the 4 bits for timer 1, and then gate C/T bar M1 M0. These are the 4 bits for timer 0. Okay, now the upper 4 bits are same as that of the lower 4 bits. We can see from this, but they are meant for different timers. The upper 4 bits is meant for timer 1, the lower 4 bits is meant for timer 0. Now let us study what are these bits. What is gate bit? What is C/T bar, M1, M0? Bits of the TMOD register. Let us see them individually. What is the function of these 4 bits? Okay. Let us take up the first bit, that is the gate bit. Now this gate bit, when it is 1 and TRX bit, when it is 1, TRX bit when it is 1, okay, and INTX interrupt bit, external interrupt bit, that is also 1, okay. The hardware controls the timer. The hardware controls the on and off of the timer, okay. So it's coming under the hardware control, okay, hardware control, right. Next condition, the timer operation is controlled by the hardware circuit. Now if gate equal to 0, next condition, gate is equal to 0 and TRX X is equal to 1, then it is controlled by the software. The on and off of the timer is controlled by the software. Okay. This is for hardware control, the first condition. The first condition. Gate equal to 1, that is this bit is 1. TRX, timer run control bit. This is the bit in the TCON register which we'll be studying next. Next I will be explaining the TCON register where you'll be studying the TRX bit. TRX is equal to 1, timer 1 run control bit, and then INTX, external interrupt bit, external interrupt bit. Okay, so external interrupt, there are how many interrupts? Can you recollect how many interrupts are there in 8051? 8051 microcontroller has got how many interrupts? Can you recollect? There are 5 interrupts, is it not? Which are those 5 interrupts? One is the timer 0 interrupt, timer 1 interrupt, serial communication interrupts, serial port interrupt, and then external interrupt 0 and external interrupt 1. These are the 5 interrupts of 8051 microcontroller. Which are the 5 interrupts? The timer 0 interrupt, timer 1 interrupt, serial port interrupt, external interrupt 0, external interrupt 1. These are 5 interrupts of 8051 microcontroller. Remember. Now this is INTX. Here X can be 0 or 1. X, if it is 0, it is for timer 0. If X is 1, it is for timer 1. Similarly here, INTX. If it is INT0, it is external interrupt 0. If it is INT1, then it is external interrupt 1. Okay. Now, why this INTX is made high? External interrupt is active low pin. That is why it is made high. Okay. If it is made low, then it will get activated. External interrupt will get activated. We don't want external interrupt now. We want only for timer operation. Therefore, we are making this INTX pin high. It is active low pin. We are making it 1 so that it is deactivated. Okay. Now, for the software control, the condition is gate equal to 1 and TRX bit in the TCON register. TRX stands for timer run control bit. TRX stands for timer run control bit. So this TRX is equal to 1. This is for the software control. Software control. Okay. So one is for the hardware control, this condition, and the second condition is for the software control. Now, what is meant by hardware control? Hardware control means the hardware circuit, that is the microcontroller circuit or the electronic circuit in the microcontroller that will control the operation of the timer. Now, software control means the instructions that we are using, the instructions written by the programmer that will control the operation of the timer. Now, for example, if we want to turn the timer on, okay, if I want to turn the timer on, instruction that I'm using is CTB set bit TR0. This is for turning on timer 0. Set bit TR0 means TR0 bit will become equal to 1. TR0 bit will become equal to 1. Okay. Next, set bit TR1. Set bit TR1. TR1, that is here TR1 will become equal to 1. TR1 will become equal to 1. That is timer 1 will be turned on. Now, if I want to turn off the timer, then I have to use the instruction clear TR0, clear TR0. This means TR0 is equal to 0. Timer 0 will be turned off. Then here TR1, clear TR1. This indicates TR0 it is. TR0. This indicates that TR0 is equal to 0. The timer 0 will be turned off. So timer 0 turned on, timer 0 turned off, timer 1 turned on, and timer 1 turned off. Timer 1 turned off. These are the instructions that are used, the software instructions to turn on and turn off the timers. Okay, that is nothing but the software control. The software control. Clear here? Now this is about the gate bit. This is about the gate bit. That is the first bit. Now second bit is C slash T bar. It is counter bar timer. C means counter, T means timer. C stands for counter and T stands for timer. So C slash T bar. C slash bar it is T bar. So this is C slash T bar. It indicates that either the counter is activated or the timer is activated. Either the counter is activated or the timer is activated. Okay. Right. So if we want to make use of timer as a counter, then C slash T bar is equal to 1. If we want to make use of the timer as a timer to work as a timer, then this C slash T bar will be equal to 0. If it is 1, then it acts like a counter. If it acts like a counter. Then if it is 0, then it acts like a timer. It acts like a timer. Now, if it is working as a counter, that if it works as a counter, then the clock input is provided from the timer pin, that is T0 or T1 pin of the 8051 microcontroller. The external clock pulse is provided for the timer to work as a counter. If the timer is working as a timer, the internal clock, that is the system clock, the crystal frequency. How much is the crystal frequency? We know that it is 11.0592 megahertz. That is used to make the timer to function as a timer. Okay, to provide the clock frequency for the timer, the crystal frequency used or the system frequency is used to provide the clock frequency for the timer to work as a counter. The external clock pulses are provided to the timer pins, that is T0 and T1 pins, timer pins of the microcontroller. Okay. So this is about the C slash T bar pin. Next two bits are M1 and M0. M1 and M0. Now there are four modes of operation of the timers. There are four modes of operation of the timers. If M1 M0 is 0 0, M1 M0 is 0 0, then it works as timer mode 1. It is timer mode 1. Timer mode 0. Timer mode 0. This is called 13-bit timer. 13-bit timer. In this 13-bit timer, all the 16 bits of the timer register are not used. Only 13 bits out of 16 bits are used. How they are used? The timer high, THX 8 bits are used. 8 bits are used. The remaining 5 bits is for the timer low. From the high 8 bits, all the 8 bits are used, and from the lower 8 bits, only 5 bits are used. So total it is 13 bit. This is for timer 0. Now when it has to work as timer 0, let us see later that how it works as a timer 0. Next, if it is 0 1, if M1 bit is 0, M0 bit is 1, then it works as timer mode 1, timer mode 1, timer mode 1. This is called as 16-bit timer. 16-bit timer. 16-bit timer is all the 16 bits of the timer register is used for performing the timer operation. Okay. Next, if it is say 1 0, if M1 is 1, M0 bit is 0, it is 2, right? 0 means in decimal it is 0, 01 means in decimal it is 1, 10 in decimal it is 2. That means it is timer timer mode 2. Timer mode. So this timer mode 2 is an important timer mode. It is called as 8-bit auto reload timer. Auto reload, auto reload timer. Auto reload timer. Right? It is one of the important timer modes. It is called as 8-bit auto reload timer. The last one, if M1 is 1, M1 is 1, and M2, sorry, M0 is also 1, then it is called as timer mode 3. 1 in decimal is 3. It is timer mode 3. Timer mode 3. Timer mode 3. Okay. This is called as split mode timer. Split mode timer. Split mode timer. Here. So this is all about the TMOD register. Okay. In examination, if they ask, explain the TMOD register or the bit structure of the TMOD register, then you have to draw this TMOD register bit structure. Write the bits, gate C slash T bar M1 M0 for timer 1, gate C slash T bar M1 M0 for timer 0, and then explain these bits. What is gate, what is C slash T bar, what are M1 and M0. Okay, whatever is there for the timer 1, the same bits are also there for timer 0. The operation of these bits remain the same. Clear here? So this is about the timer modes. Mode 0, 0, 0, 13-bit timer, right? Mode 1, all the 16 bits are used. And in mode 2, THX is a register which is 8 bits. TLX is the register which is 8 bits, right? The timer high register will load into the timer low register. Starting value for the timer is loaded by THX register into the TLX register. Okay. From the starting value, the timer will start to count. Okay. For every clock pulse, the timer will start to count. Okay. Or it will start to move in the upward direction. So if the starting value says 0, 0 in the timer, then it will start to move in the upward direction as 0, 1, 0, 2, 0, 3, 0, 4 up till FF. Then after FF, it moves from FF down to 0, 0 only. This condition is called as overflow condition. I was explaining just in 1 or 2 previous classes, right? That is overflow condition. When it moves from FF to 0, 0, the condition is called as overflow condition. If it is moving from 0, 0 to FF, then it is called as underflow condition. Remember, if it is moving from FF to 0, 0, it is overflow condition. If it is moving from 0, 0 to FF value and then decrementing from FF, then it is called as underflow condition. From FF to 0, 0, counting in the upward direction 0, 0, 0, 1, 0, 2, 0, 3 up till FF, it is overflow condition. If it is moving from FF to 0, 0 and counting in the backward direction, right, FF to 0, 0 counting in the forward direction, then it is called as the underflow condition. Okay, just remember these two. Then a timer mode 3, it is 1, 1. So there are two types of timers here. Okay, so here we are using two timers simultaneously in the timer mode 3, that is TL0 and TH0. Two timers are used simultaneously. That is why it is called as split mode timer. Right? Both will be operating simultaneously. For one timer, we are applying, for timer TL0, we are applying the clock pulses from the external clock pulses to work it as a timer. For the timer TH0, timer high, we are applying the clock pulses from the crystal frequency, that is the internal clock, the system clock. From there, we are applying the clock pulses for TH0 to work it as a timer. Okay. So because of these two timers, they are working parallelly, simultaneously. It is called as split mode timer. Okay. Now this is about the TMOD register. Now based on this TMOD register, take this example. We'll take one example and then we'll move on to the different timer modes. Just note down this example. Find the values of TMOD to operate as timers in the following modes. Find the values of TMOD to operate as timers in the following modes. First one, mode 1 timer 1. Second, mode 2 timer 0, comma mode 2 timer 1. Third, mode 0 timer 1. Fourth, mode 1 timer 1, mode 2 timer 2. Noted on the example?
No, sir.
Okay, take your time. Noted down?
Yes, sir.
Okay. Read the statement. Find the values of tmod to operate as timers in the following modes. That means we have to find out what is the value in tmod register if the timers are working in these modes. Suppose say the first condition is timer 1 is working in mode 1, then what is the value that will be stored in tmod register? That we have to find out. Let us do that. First condition is timer 1 mode 1. Timer 1 mode 1. Are the bits here? 8 p slash t bar, c slash t bar. Okay. M1 M0, M1 M0, and similarly the same will repeat for the timer 0. Gate c slash t bar M1 M0. Okay. So it is t bar here. Okay. Now what they are saying, timer 1 mode 1. Upper 4 bits is for timer 1, lower 4 for the timer 0. Timer 1, that means they are using upper 4 bits. Now what should be for the gate bit? Now usually when we are using these modes, right, we write the instructions. We usually go for software method. Okay, that is software method for programming these timers. So this is called as programming the timer bar counter. The topic name itself is programming the timer bar counter in assembly and C language. Clear here? Timer 1 mode 1. Now we go for software method. When you are going for software method, the gate bit will be 0. Gate bit is 0 for software control. C slash T bar. Now we are using it as a timer. Clearly it is there in the question itself, timer. Therefore, this bit is also 0. Then what about M1, M0? We are using mode 1. Mode 1 means what should be M1 and M0? 0, 1. 0, 1. Right? 0, 1. Right? Mode 1. Timer, gate, it is 0. Software control. Remember, always you are using software control only here because we are programming the timer bar counter using assembly and C language. Then timer, for timer it is 0, for counter it is 1, for timer it is 0, it is active low, timer is active low. Mode 1 is 0, 1, M1 is 0, M0 is 1. What about for the lower 4 bits? Untouched. Lower 4 bits is untouched because timer 0 we are not using. So all are zeros. All are zeros. What is the data here? Yes, please. What is the data here? 0001. It is 10H. 10H. So this is the value that we are storing in the mod register if the condition is timer 1 mode 1. Got the point here? This concept is clear here? Yes? This concept is clear? Now work out for the second condition. Okay, work out for the second condition and tell me what will be the value if it is mode 2 timer 0, mode 2 timer 1. Work out for this. Mode 2 timer 0, mode 2 timer 1. Mode 2 timer 0, mode 2 timer 1. Second condition. So here both the timers are used. Timer 0 is also used, timer 1 is also used. Right? And timer 0 is used in mode 2, timer 1 is also used in mode 2. Now first note down the bit structure. Gate C slash T bar M1 M0, gate C slash T bar M1 M0. Then substitute the bits accordingly, according to the given condition. How much you are getting? Anybody tried out? Mode 2 timer 0, mode 2 timer 1. Has anybody tried out? Yes, please. Let me explain. Mode 2 timer 0, mode 2 timer 1. Mode 2 timer 0, mode 2 timer 1. Okay. Now substitute. I'll take the same as above. Gate C slash T bar M1 M0, gate C slash T bar M1 M0. Now gate bit, it is clear, it is software control, so it is 0. We are not using the hardware circuit here. Then mode 2 timer 0. So first come to timer 0. This is lower 4 bits for timer 0. So gate bit of that, it is 0, 0, right? Then C slash T bar, it is timer, so this is also 0. Mode 2, M1 M0 should be how much? It is 2. Yes, anybody? How much?
10.
1 0, exactly. 1
0. 1 0.
0. 1 0. Decimal 2, right? Simple. 1 0 is for decimal 2. So it is mode 2, right? Now we are done with mode 2 timer 0. Now come to timer 1, upper 4 bits. First bit is gate, that is 0, that is sure. Then C slash T bar, it is timer. They are mentioned in the question. This is also 0, second bit. Then what about M1 M0? Timer 1, mode 2. That is also mode 2. Correct? Mode 2 timer 0, mode 2 timer 1. So it will be same 0 0. It is both are same. Okay, just timers are different. It is 0 0 1 0. Right? 0 0 1 0 0 0 1 0. What is the answer? 0 0 1 0 is how much? 4. 0 0 1 0 is 4. It is 44. 44. Similarly, tell for the third one, students.
Sir,
Mode 0
22
timer
sir.
1 is how much?
22 sir.
22 aketri?
Sir, ಅದು 44 ಅಲ್ಲ sir, 22.
Sorry, correct. Right, thank you, Nandish. 22. Yes, 8 4 1 22. Good. Next condition. Mode 0
Sir,
timer 1.
sir,
Here, Nandish.
ಅದು
ಹೇಳ್ರಿ ನಂದೀಶ್.
ಸಿ ಬಾರ್ ಟಿ 1 ಆಗ್ತದಲ್ಲ ಸರ್, ಅದು ಎರಡರಲ್ಲಿ ಒಂದಲ್ಲಿ ಟೈಮರ್ 0 ಐತಿ, ಒಂದಲ್ಲಿ ಟೈಮರ್ 1 ಐತಲ್ಲ ಸರ್.
ಹಂಗಲ್ರಿ ನಂದೀಶ್, ಒಂದ್ ನಿಮಿಷ ಹೇಳ್ತೇನೆ ನಿಮ್ಗೆ. ಇದು ಟೈಮರ್ 0 ಅಂದ್ರೆ ಏನ್ರಿ? ಲೋವರ್ 4 ಬಿಟ್ಸ್. The lower 4 bits in the what are there, right? These lower 4 bits are meant for timer 0. Therefore, controlling the
Yes, sir.
operation of timer 0. Okay. Here, this M1, M0, they are meant for mode setting of the timer. Remember, and gate and C slash T bar are meant for controlling the operation of the timer. Right. The lower 4 bits is for timer 0, and the upper 4 bits is for timer 1. Timer 1. Clear here. Lower 4 bits,
Yes,
these
sir.
are meant for timer 0, upper 4
Yes,
bits is
sir.
for timer 1. Right. Now it is clear. Any doubts, Nandish? This timer 0, here mode
No,
to
sir.
timer 0 means we are
No,
using
sir.
the lower 4 bits, right? And mode to timer 1 means we are using the upper 4 bits. Mode 2 means it is 1 0 here also, and here also it is mode 2, it is 1 0 here also. Just substitute and find the value. Got the point, Nandish?
Yes, sir. Yes, sir.
Okay, fine. Quickly find out for the third condition, mode 0 timer 1. Mode 0 timer 1. How much it will be? Mode 0 timer 1. So they are using only upper 4 bits. Lower 4 bits are untouched. That is, they will be 0 only. Lower 4 bits. Mode 0, timer 1. Timer 1 means upper 4 bits. Mode 0. So what will be the bit structure? Gate is 0, C slash T bar is 0, M1 is 0, M0 is 0. Right? And the lower 4 bits, they are untouched. So they will also be 0, 0, 0, 0. So the answer is 0, 0H. Am I right? Mode 0 timer 1. Timer 1 upper 4 bits. Mode 0 means both the bits are 0. M1 is 0, M0 is also 0. Correct? Then timer 0 is not touched. They are not given any condition for timer 0. That means they will be 0. All the 4 bits of timer 0 will be zeros. Therefore, the answer is 0, 0, 0, 0. Then the lower 4 bits are also 0. That is, it will be 0, 0H. Clear here? Similarly, work out for the fourth condition. Tell me the answer tomorrow.
Sir.
Right?
Sir.
Here, Nandish.
Sir.
Here, here,
ಅದು ಸಿ
Nandish.
ಬಾರ್ ಟಿ ವ್ಯಾಲ್ಯೂಸ್ ಹೆಂಗ್ ಸರ್ ಕಂಡುಹಿಡಿಯೋದು? ಸಿ ಬಾರ್ ಟಿ ವ್ಯಾಲ್ಯೂಸ್, ಸಿ ಟಿ ಬಾರ್ ವ್ಯಾಲ್ಯೂಸ್.
ಹೇಳ್ತೇನೆ. C slash T bar, see here, C stands for counter. Okay. T stands for timer. Fine. Now, suppose say if in the question, if they give mode 0, counter 1, then what we have to substitute? Mode 0, counter 1. Okay. Mode 0, counter 1.
Sir.
So counter
ಸಿ
1
ಬಾರ್
is for
ಸಿ ಟಿ
the
ಬಾರ್
upper
ಈಕ್ವಲ್ಸ್
4
ಟು
bits.
1.
Yes, you are right, exactly. C slash T bar will become equal to 1. The C counter is, C stands for counter, T stands for timer. If in the question they mention it as timer, then means you have to substitute as 0 because it is active load, T bar it is, right? If in the question they mention it as counter, right? Mode 0, counter 1, mode 1, counter 0, right? Mode 2, counter 1, mode 2, counter 0, like that. That means you have to set this counter. Okay, you have to make it 1. The second bit, C bit should become equal to 1. Mode 0, counter 1. Counter 1 means upper 4 bits. I'll write it. Software control gate is 0. Then counter it is, so make it 1. It is mode 0, so it will be 0, 0. Right? Counter 1. Then the lower 4 bits, counter 0. Timer bar counter, it is, remember. Timer bar counter. So timer 0 bar counter 0. Timer 1 bar counter 1. Okay. So lower 4 bits are 0. They are untouched. 0, 0, 0, 0. So the answer is 0, 1, 0, 0, 0, 0, 0, 0. So it is 40H. 40H. Have you understood here, Nandish?
ಎಸ್ ಎಸ್ ಸರ್. ಮತ್ತೆ ಗೇಟ್ ಯಾವಾಗ ಒನ್ ಇರ್ತದೆ ಸರ್? ಮತ್ತೆ ಗೇಟ್ ಒಂದು
ಗೇಟ್
ಎಕ್ಸಾಂಪಲ್
ಯಾವಾಗ ಒನ್ ಆಗ್ತದೆ ಅಂದ್ರೆ ಹಾರ್ಡ್ವೇರ್ ಕಂಟ್ರೋಲ್ ಇದ್ದಾಗ. ಹಾರ್ಡ್ವೇರ್ ಮೀನ್ಸ್ ಇಫ್ ಇಟ್ಸ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಸರ್ಕ್ಯೂಟ್. ಇಲ್ರಿ ಎಕ್ಸಾಂಪಲ್ ಅಂದ್ರೆ ಹೆಂಗ ಪ್ರೋಗ್ರಾಮಿಂಗ್ ಅಂದ್ರೆ ನಾ ಇಲ್ಲಿ ಟಾಪಿಕ್ ಏನೈತೆ ಅಂತಂದ್ರಿ, ದ ಟಾಪಿಕ್ ವಿಚ್ ಇಸ್ ದ ಮೆಂಟ್ ಫಾರ್ ಸ್ಟಡಿಂಗ್ ಹಿಯರ್ ಇಸ್ programming the timer bar counter, using assembly and C language. Okay. Now programming means we are programming these bits. right? Suppose say if in the question if they mention it as hardware circuit, that's a good question asked by Nandish. See, if they are asking like using a hardware control method, okay, if they are not giving any condition, anything, if they are not mentioning, it is by default software condition only, right? Software control. Suppose in the question if they mention by hardware control, okay, then what we have to do, we have to make the gate bit 1. We have to make this gate bit 1. Then whatever according to the condition, timer 1 mode 1 or timer 1 mode 0, we have to set the other bits. Got the point, Nandish? Nandish?
Yes, sir.
Okay.
Sir,
Yes, sir.
ಹೇಳ್ರಿ ಶಾಬಾಜ್.
sir, timer 1 mode 1 ಇದ್ದಾಗ ಸಿ ಬಾರ್ ಇದ ಸಿ ಬೈ ಟಿ ಬಾರ್ ಅದಲ್ಲ ರೀ, ಅದ 0 ತಗೋಬೇಕು ಅಂತ ತಗೋಬೇಕ್ರಿ.
ಟೈಮರ್ 1 ಮೋಡ್ 1 ರೀ. ಟೈಮರ್ 1 ಅಂದ್ರಿ ಇಲ್ಲಿ ಅಪ್ಪರ್ 4
0,
ಬಿಟ್ಸ್
0,
ರೀ.
sir.
One minute, I will explain. Timer 1 mode 1, okay. Look at the question, try to understand it before writing the answer. Timer 1, so our timer 1 is for upper 4 bits, right? Then it is sure that we have to make use of upper 4 bits only, the upper 4 bits, right? Then mode 1 means the M1 M0 will be 0 1. 0 1 in decimal is 1, correct? Mode 1. Then set the other 2 bits, gate and C slash T bar. Gate will be 0 for software control by default, and C slash T bar, it is timer, therefore T bar, that is active low, that will be 0. Therefore the answer will be 0 0 0 1. Then the timer 0, they have not given any condition for timer 0. That means by default they are all zeros. They are untouched, so they will all be zeros. Clear here? The answer will be 1 0 H. Got the point, Shabas?
Yes, sir.
Okay. Any other questions here? I hope everybody
Sir, we have
understood.
to use T bar only.
T bar, yes, it is T bar only.
Sir, T.
No, it is not T, it is T bar. C slash T bar it is. T bar stands for active low. You have studied already this in your digital, right? So it is T bar stands for active low. It is active low, that is active low active low bit here, right? Therefore, if it is T bar, we have to set it as 0. If it is counter, then we have to make it 1. Counter is active high, C is active high. There is no bar on the over the counter. C over, there is no bar, but over the T there is a bar, complement is there, correct? Therefore it is T bar means we have to make it 0. Understood?
Sir,
Here
sir, sir, timer 1 active high ಇದ್ದಾಗ ಆಗುತ್ತೇನ್ರಿ?
timer 1 ರೀ. ಹೇಳ್ರಿ ಶಾಬಾಸ್,
C slash T bar, ಅದು C slash T bar ಅದಲ್ಲ ರೀ,
ಹಾ ರೀ ಹೇಳ್ರಿ.
ಫಸ್ಟ್ ಕಂಡೀಷನ್ ಒಳಗ 0 ಅದ ರೀ, ಯಾಕಂದ್ರೆ ಆಕ್ಟಿವ್ ಲೋ ಅದ ರೀ. ಅದ 1 ಯಾವಾಗ ಆಗುತ್ತ್ರಿ?
1 ಇಲ್ಲಿ ಕೊಟ್ಟೆ ನೋಡ್ರಿ ಎಕ್ಸಾಂಪಲ್. ಮೋಡ್ 0 counter 1. Counter 1 ಇದ್ದಾಗ when it is working like a counter, when the timer works as a counter to count the number of events, to count the number of tasks, to count the number of jobs, right? Then it will be set to 1 because it is C slash T bar. C slash T bar, correct? Counter bar, timer bar. So C will be 1 and we have to set the remaining bits accordingly, whether it is mode 0 or mode 1 or mode 2 or mode 3. Understood here, Shabas?
ಅಂದ್ರೆ ಕೌಂಟರ್
ಹೇಳ್ರಿ
1 ಇದ್ದಾಗ ಅಷ್ಟೇ ಆಕ್ಟಿವ್ ಹೈ ಇದೆ.
ಏನತ್ರಿ? ಕೌಂಟರ್ ಇದ್ದಾಗ ಅಷ್ಟೇ 1 ಇರ್ತೈತ್ರಿ. ಹೌದ್ರಿ. when it is counter it will be 1, when it is timer it will be 0. ಇಷ್ಟ ನೆನ್ಪಿಟ್ಕೊಂಡ್ಬಿಡ್ರಿ. ಕೌಂಟರ್ ಇದ್ದಾಗ 1 ಸೆಟ್ ಆಕತಿ because it is active high. ಇಲ್ಲೇ ಗೊತ್ತಾಕತ್ ನೋಡ್ರಿ. C ಅಂತ there is no bar here. C complement ಇಲ್ರಿ, correct? Therefore it is active high. So you have to decide based on whether it is active high or active low. Don't try to by heart the things. Try to remember if it is active high, right, it is 1. If it is active low, it is 0. Timer is active low, we have to make it 0. Understood here, Shabas?
Okay, sir.
Okay, fine.
Yes,
anything
sir.
else? Anything else? Okay.
No, sir.
Fine. Then in the next class, I will be explaining these timer modes, these different modes, mode 0, mode 1, mode 2, and mode 3. And then I will come to the take-on register. Okay. That will take up in the next class. Thank you.
Sir.
Here, Nandish.
M1 M0 11 ಇದ್ದಾಗ M1 M0 11 ಇದ್ದಾಗ ಏನು
ಮೋಡ್ 3 ಆಗ್ತೈತ್ರಿ ಅವಾಗ. ಇಲ್ಲ ನಾನು ಸಪೋಸ್ ಮೋಡ್ 1 ಟೈಮರ್ 1 ಮೋಡ್ 3 ಅಂತ ಕೊಟ್ಟನೆ ಅಂತ ಇಟ್ಕೊಳ್ರಿ. If I am giving it as timer 1 mode 3, right? Then it will be 0 0 1 1. That's all. So 0 0 1 1 means it is 308. Answer will be 308. Got the point here,
ಅಂಡರ್ ಫ್ಲೋ
Nandish?
ಓವರ್ಫ್ಲೋ ಕಂಡೀಷನ್ ಏನ್ ಬರಲ್ಲ.
ಇಲ್ರಿ ಅದು ಯಾವಾಗ ಬರ್ತತ್ರಿ when the timer starts to count, when the timer starts to move in the direction. Next class I explain ಮಾಡ್ತೇನೆ, ಅಲ್ಲಿಗೆ ಬರ್ತೇನ್ರಿ ನಾನು. Next class I am taking up that only, how the timer works, how it overflows. Okay, what happens when the overflow condition occurs? There will be interrupt occurring. That I will take up in the next class. That will be clear to you there. Next class I'll come there. I'll come there and I'll explain
Yes, sir,
what
yes, sir.
happens when there will be overflow condition, when the timer counts. So when the timer counts from 0, 1, 2, 3, 4 up till FF, after FF again it has to come down to 0 and start again from 0, 0 condition. 0, 0, 0, 1, 0, 2, 0, 3 up till FF. So that condition which is going from FF to 0, 0, that will cause overflow condition. Got the point here? If it is in the opposite way, then it is underflow condition. Getting the point here, Nandish? I hope it is clear, Nandish.
Yes, sir.
Okay, fine.
Yes, sir.
Yes, we'll continue in the next class, right? Thank you.